Hello, everyone. Welcome to pipeengine.com. Today, we are going to make a tutorial video to introduce our load analysis tool dedicated to corrugated HDP pipe. So this tool, was developed based on the publications corrugated plastic pipe handbook, especially all the equations, method, and parameters included in Chapter 7, Structural Design. This publication is released by Plastic Pipe Institute. It's really just to help the designers, engineers to evaluate the structural capacity of a bed-rated corrugated HDP pipe. We all know in recent years, corrugated HDP pipes become increasingly popular in many civil and municipal projects, even for the penstock applications too. But to do the calculation, if you have done it before, you probably know that it has to go through a lot of tables, a lot of different parameters in different sections of this publication, and there's a lot of interpolations too between different factors. So it can be getting pretty comprehensive. So we make this tool to hopefully make the whole process a lot easier. So let's cut to the chase. Let's get into the tool itself. First of all, like all our other tools, we do offer imperial or metric units. But for today's tutorial video, we're gonna just rely on imperial units. So the first section of this tool is really about the pipe specifications. We are talking about the pipe outer diameter pipe. This is really the true outer diameter, including the corrugated section. And on contrary, also we want to know the inside diameter. For the long-term creep modulus of pipe material, this is related to the HDPE material itself. There are typical values we could use. That all depends on what is the design life of these pipelines. So for typical values, depends on the HDPE or the plastic pipe. We have short-term or long-term parameters. So usually is for temporary application, you could use the short-term. But if you design it for more of a permanent application, typically if we're not sure that the design life, you can typically set it to the 75, which is very typical design life for any piping system. Or you can go a little bit less conservative and go for a 50-year, which is also widely acceptable. So if you want to know the quick check about the parameters, you could just click the button here. There's a quick table. You could just select the parameter really quick. So in this case, we are using HDP pipe, and we are assuming 75-year design life. So we can go for 21 KSI. And then for short-term creep pipe materials, similar things. There's a table for a typical value you could use. So in this case, it's gonna be 110. So and then we comes to the pipe material tensile strength. Again, make it easier for everyone. Just click on the table so you could see that for long-term 75-year design life for HDPE, it is 0.9 KSL. So and for moment of inertia of the pipe per unit length, so all this and including the corrugation gross area, so all these parameters, they're typically provided by the pipe manufacturer. So if you're not sure what is the parameter, you either go to the pipe you plan to use, or you propose, you go to their catalog, define this parameters, or you can ask the pipe vendor to provide that for you. Similar things for static compression test capacity, and you just get this from the pipe manufacturer. For time factor to account for design load duration is a KT. Similar things, go click this button and you get short term 50 years 75. So in this case it's going to be 75 years, so it's going to be 0.25. Coming down here, based on the parameters, we put it on the left hand side. This tool is gonna calculate the corrugation effective area, the radius of pipe to central wall, all this critical stuff. And then we go to the second section to put more of the soil properties. This is the trench width. Basically, you're gonna design the trench based on the pipe diameter, and also you have this constrained modulus embedment materials. So this is a little bit complicated to get, which we actually make the process a lot easier. So what are you gonna do is gonna click the reference, and you can tell there is a drop down menu to show you how many class, what's gonna be the class embedment materials. They all have all different types and different values pretty much. So typically class 1 is for the rocks, and class 2 is more common, and you can tell this table will show you different values and for different compaction, and you can even choose the compaction based on what you plan to do. It's 90 or 95, and what is going to be building about this is based on the depth we put it in other part of the tool, and based on the selection, we can do the interpolation by itself and to give you the really the value here. And again, this is an interpolation based on the numbers and also the inputs you put it in. So in this case, it's going to be 1336. And you can come in here and put a 1336. So make that process fairly easy. And we have a little bit tip here to show you what to do. Similar things for the native soil. Again, you can click to the reference. They have all this typical value you could consider for different soil types and different depth. And you could just put in something based on what you see in the field for this project. And this tool is going to calculate the ratio of MSN, MSB, and the ratio of the BD and DD. So to really calculate the support combining factor, which also require some additional interpolation. So you could open it up to see the real table for a typical how based on different ratio, different total trench ratio, you get different factors, and then you have to do interpolations. And this tool is gonna just do that for you, make it super easy. And so everything combined, we will get to the composite constraint modulus data, which is gonna be calculated here. And then we can get into the inputs for the data load and high hydrostatic load. This is really related to soil load and also the groundwater. So you could put in the depth cover here. For example, you can put a 3 in this case. Moisture weighted soils, if put it in 120 pound per cubic foot is just a standard typical value. And a saturated unit weight of the soil. And maximum effect height of groundwater. So this is all needs to come from some geotechnical investigation. So to put that in, and this factor for uncertainty level ground table. So if you're certain, put in 1. If not too much, you can put 1.3, just to make it more conservative. And once you put that all that in, this tool is going to calculate all this critical parameters by itself based on your inputs. Circling down to the live load. So there's a drop down menu you could use. First of all, is like the design track, which is a standard HS20 load, which is pretty much widely used for any case that to have a regular vehicles. Or you can, if it's a railway above it, you could put in the railway E80 railway live load. Or if it is even over HS20 load, which is kind of rare, but if you have a really large equipment, you could select the owner specify. You can manually put all this parameters in, but I would say 90% of chance you probably go with the design track load, typical design track load for HS20. And then this 32,000 pound is really for HS20 load. And you then you can put in the multiple presence factor, and we have a tip for you. So if it's a single loaded lane, if a single lane crossing this pipe, you could put a 1.2. If it's like two adjacent lanes, you could put a 1.0. And it will then calculate the dynamic load allowance, wheel spacing, axle spacing. This is a default based on the selection of the HS20 load. It's going to be a little bit different if you go with railway load. It's going to be default, like change to more suitable for the railway load. You're pretty much getting here. Or specify one, then you have to manually go through everything. So again, I'm going to go back to HS20, and they pretty much just calculate everything you need to have, and it was going to calculate pretty much all this critical life load distribution. Again, when you have a different depth, your pipeline is going to see the overlap load distribution from one wheel load, point load, or from a two combined or even more. So this is really just to help out to really streamline that process to make it super easy. And then going down here, there are other multiple load check. This standard process for this design approach. And in this case, we gonna pretty much automate it for multiple things. All these factors pretty much goes to the default, and you can see the result to see the check if it's pass or fail. Again, for example, for installation factor here, I want to highlight we have the similar feature for all our tools that if you want to manually change this factor, for example, here you want to go for a little bit less conservative, you could just click here to put it like, for example, 1.35 in this case. So you can just click here to manually override the standard value. Same thing for load distribution. For this case, we're gonna just, if you're not sure, just keep it to the standard setting for the parameters. So apparently for hoops thrust check, everything's passed. You can go through all this different calculation, different parameters. And then we come here for deflection check. Again, for bedding, there's a typical range. You could click here to really change this factor. And same thing for deflection lag factor. Also, the design allowable pipe deflection factor, you can change it based on the DR. So, or what is more comfortable, your design basis. You could click here to change the limits. And the pipe stiffness, again, this is something calculated. But if you know the real value from the pipe manufacturer, click here to put the real value in. And for shape factor, this is another, we provide a reference for you. Basically, it does have different pipe stiffness and different soil property. It's going to give you a different value. Of course, you can change the compactions based on the drop down. For example, in this case, it's going to be gravel moderate to high, and give you a shape factor from interpolation, and then they give you the number here. So again, make this process super user friendly. And then based on these inputs, you will have all the calculations. You will show a pass or fail right here. The next one is gonna be for global buckling design check. Again, this is a Poisson ratio. 0.3 is typical, but you could change that for the soil if you know it. And flexibility flag check is a pass. And the buoyancy force check, if you can actually bury it below the underground water table, so you can choose applicable, and we'll do this calculation to tell you, do you need additional buoyancy control or not? Because, it's a large, typically for large bore corrugated plastic pipe, it's gonna flow when you doing the installation. If it's not applicable, you could just choose not applicable. Then it's gonna really disable this whole sections. So for this case, let's keep it applicable. So that's pretty much everything about this tool. And lastly, I want to say that we do offer a few unique features. Pretty much, we have all our other subscribe the tools. You can either choose to save your calculation to the cloud server by saving it, put in the file name. You can revisit this next time you log in, or you can download to the local drive with the file, and you can open that file through this feature here, or you can print it out a PDF report function. It's going to generate PDF files you can download and file it for your project. So again, that's pretty much everything about this tool. If you have additional questions, feel free to contact us. So thank you very much.